So now we get to go play. So play day. We're going to go play for the next 50 minutes. So Wireshark. Everybody know what Wireshark is? It is a packet sniffing program. So when you get to here, just click on next. You want to agree to everything. Give it everything that it wants. And then go ahead and just go through and just install it. Yep, just install it. And one of the things you're going to see, install WinPCAP. WinPCAP is the fundamental program for a lot of the software you are going to use in this class. WinPCAP is what's called a low-level packet driver. What it does is it puts your NIC card, your network interface card, into what's called promiscuous mode, right? So that it will actually see everything that's going across the network rather than just stuff that's addressed to your particular IP address, right? So if you have a problem with any of these programs, it's probably going to be WinPCAP that's going to be your issue, all right? So make sure that it installs WinPCAP, and then just go ahead and click on install. And it will go through and do its whole thing. Do what it wants to do. It takes a couple minutes. And then it should pop up with a WinPCAP screen here in a minute. All right. When you get to WinPCAP, just go ahead and install that like you would anything else too. All right. Agree to everything. And then go ahead and then it will go through and do all the rest of the stuff it needs to do. And then go next. And then once you've got it, let's go ahead and we'll run it. All right. So this is my WinPCAP. This is my Wireshark. So it looks like an awful lot of stuff, doesn't it? Right? So everybody pretty much so here on the same screen, or are we still loading stuff? All right. Nope, I just want you guys to install it. No updates yet. Just go ahead and install it. You guys can always update later. All right, everybody with me? Everybody got it installed and running and good to go and happy and they see this screen? All right, look for the little green shark fin. It says start a new live capture. It's on the little icon bar. It's the third one over from the left. And then go ahead and click on that, if it will let you. Start. Forgot to specify an interface. So, local area connection, that's the one you want. If you choose the VirtualBox one, it will only show you what's going on with VirtualBox. Huh? Nope, that's cool. If you've only got it. Yep. So, if you always choose a local area connection, it will show you your wireless connections and everything else. I've got a lot of VMware on this. And then go ahead and click on Start. And then what's going to end up happening is you're going to pull everything that's coming across the network, and you can kind of see what's going on. So what runs on port 25? What's port 25, folks? Going once? Huh? Email runs on port 25. It's called SMTP. All right. What's the port for POP3? What's the port for HTTP? What's the port for HTTPS? What's the port for NNTP? All right, yeah. All right, we're going to have to play a game here on port numbers and assignments. Yeah.
Okay.
Yeah. No, we'll play it. But yeah, no, you guys have really got to know what the port numbers are, and you got to know what a protocol is. What's ARP? ARP. That is correct, sir. What is DHCP? Okay, you've got two. Everybody else gets to answer that. What is browser? What is the browser protocol? What is it specific to? No. So it's Microsoft, port 136. All Microsoft networks talk on port 136, 137, 445. Right? Because Microsoft loves a great big huge happy Microsoft-centered network, right? So, what is TCP? Control protocol. What part does it play in the TCP/IP stack? You guys are going to get...
Which level? 1, 2, 3, or 4, or 5, or 7?
What part, when you're building a packet, does TCP play?
I don't remember.
Okay. All right. All right.
For my notes even on this, and I didn't find this. I'm going to have to go and recreate this stuff.
Yep. All right. Well, we'll cover it in class. We kind of have to. What's UDP?
Universal Datagram Protocol.
Okay. What is the significant difference between TCP/IP and UDP?
UDP isn't as secure, right?
TCP/IP has a three-way handshake. It's there for connection-oriented communication. UDP is what's called fire and forget. It don't care. It just sends a whole bunch of stuff out, and if you get it, you get it. If you don't, you don't. Most video games work on UDP, which is really, really fun when you UDP storm the Comcast network when someone's got a game going. Just saying that you shouldn't do that. It's bad. All right. So I'm actually on the school network because the school network is tons more interesting than the network here in this room, right? And you guys are seeing little red stuff pop up every now and then. You're seeing broadcasts. You're seeing a whole bunch of really interesting things. So I'm going to kind of stop this now. We've had a couple minutes to do this. If you want to change things around, you can actually click on the protocol tab, and it will actually break everything out by what protocol you're using here. So ARP. So if you have an ARP that's 10.29.255.251, who has this tell 10.29.99.158? What is that telling you? Nope. What it is, it's going back and saying, I'm 10.29.99.158, and I need to know what the route is. Who has that route to 255.251? Because I can't find it, I need to find out where it is. So who's got the route so I can get to that computer system? Right? And that's exactly what you're going to see in ARP. When you open up and start playing around with some of the other software in here, you're going to have an option to poison the address resolution protocol in this lab. And what that does is you're going to fake being the gateway over here at 203.1. So what you're going to do is you're going to actually, when you ARP poison, how many packets does it take to get a Cisco router to drop into hub mode? You guys remember that from my 160 class? 50,000, right? So what you do is you send out 50,000 ARP requests, and you get that switch, the blue one or the beige one, to drop into hub mode, which means then you can actually manipulate the ARP table inside that box via software. So if we're up on an ARP poisoning software here, right, we could actually manipulate the Highline network to route through my computer rather than through the router switches and hubs like it would normally would, which means then I would have access to all of the data crossing the network, right? Because in a switched network, what does the router actually do? In a switched network, what does the router actually do? It sends data to a specific computer. In a hub network, it just throws packets all over the network, right? So the only thing you're going to ever see on a switched network is anything that's broadcast, anything that's browser, anything that's specific for your computer. It's critical to get that router, switch, or hub to drop into hub mode, because that's the only way you're going to see everything that's on the computer network, right? So ARP poisoning is one real big classic first attack that you're going to do. Just make sure your computer's beefy enough to actually handle all the traffic, right? There's nothing worse than having a packet storm and not being able to actually handle it. So 10.29.200.1 is trying to find a route to 10.29.0.1, right? This guy's trying to build his own routing table, 137 or 237, 251, and it's not getting the answer back he wants, right? Or one that's not an available route. So that tells me a lot about how this network is configured. If we have a bunch of stuff pointing places that don't exist, because that means I can fake out and take over that identity. If 237 does not exist, I can become 237. And then I can set up a static route on my computer and play router for the network. And if I'm playing router on the network, and all of a sudden I have a valid route on the network, that means I can see everything across that valid routing schema, which is a good thing, right? This is why network engineering is 100% absolutely honking critical, because you want to make sure all your routes are in place. right? Because you do not want someone like me coming in and saying, oh, you've got a route that doesn't really exist. Well, here, let me fix that for you. Right? Because then all of a sudden I become infrastructure gear and you may not even notice it, which is generally a bad thing, right? 227 was trying to do the same thing, 158, 227. So lots of ARP, right? It's coming from just a couple of computers. I already know that I'm 158, right? Just because I've been doing this for a couple of days. So Dell, what's a MAC address? What do the first 3 octets of a MAC address tell you? The manufacturer. The rest of it's unique to the device ID. So Apple 001 Charlie Bravo 3. So if there's an Apple device on this network, what this software will do is break it out. It's a Dell computer with this unique ID 6006F2. And again, that's my computer, so I'm okay with that. Well, that's not my computer. This tells you it's a Cabletron. What is Cabletron? It's a switch. So if the Cabletron is looking for 10.29.0.1, if a switch is looking for a route, can I become that route? And if I'm the route on a switch in its ARP table, what ends up happening? That switch is going to send me everything destined for 10.29.0.1. Now, the dead giveaway on this is if I'm a hacker, is I'm going to have to talk to it in my MAC address and say I'm Dell. But who's to say I'm not Cabletron 863B52? Because I can forge a MAC address. That's just more software. That's really easy to do. Right? So I can come up as a brand new Cabletron on the network. How many people think would notice that? Not enough. Not enough people would notice that. Right? So all I've done is run a packet sniff, and all I'm doing is looking at ARP. I've been packet sniffing for less than a minute. I already have 2 valid lines of attack into this network. Ones that are like super simple, ones that won't cost me anything, ones that will make me look like something I'm not. Would you allow your employees to be running Wireshark on your internal network at work? No. Do you want your network engineer to be running this thing? Yes. Yep. So kind of fun. Again, so destination broadcast means that in a switch network, it's sending it to everybody and its brother. Yes. It's a switched network. It's a switched network, so all I'm going to see is broadcast traffic or stuff that's directly aimed at me. Right? So broadcast is going to go everywhere. In a switched network, broadcast is still going to go everywhere. We're only going to see stuff that I can see. So lots and lots and lots and lots and lots of ARP that's really centering on a couple of computers.
I have one ARP.
Yep. Okay, what's a browser? What's a host announcement? Anybody remember that?
What?
A host announcement? All right, so the computer, which we don't know what it belongs to, we don't know who it is sending out what's called a host announcement. It says, hey, I'm here. I'm available. I am a Microsoft computer because the letters SMB inside the packet. System message blocks, right, is the big way that Microsoft computers talk to each other. In a Linux network, you need to use a program called Samba to do this, right? So Samba will actually translate between Linux and a Windows environment, right? But that's exactly all a host announcement is. Hey, I'm here. I'm a workstation. I'm running server NT. I'm happy. I'm available. Anybody want to talk to me? So it's the Microsoft Browser Protocol. That's exactly what it is. The workstation name is 2930-9C7. So building 29, room 309, Charlie 7. So we're actually seeing stuff from up on the 3rd floor, which is actually really kind of cool because switch network, I'm going to see all the broadcasts, right? So here's the fun part. Anybody ever go into their network and just let Microsoft go for a minute? all the stuff that I'm talking right now is system message blocks, and it's going out and it's trying to find out who all's out there, right? Who all's actually on the network that I can actually talk to. So Microsoft makes for a really interesting environment. Everybody know about the $, the admin $ shares in Windows? Did you guys get that yet? Have you heard about that? Open shares? We'll talk about open shares then in a little bit. So it takes a while, but I'm talking all system message blocks, and what I'm doing is I'm trying to build a network of where everything is on the network. TR banks, so we actually have someone else's computer here at 98.130. Right? Passport, the passport servers are Copeland's. So we're now starting to get names, and we can now start figuring out the naming convention for the computer systems on the network. Because as a hacker, what I want to do is I want to blend in as much as humanly possible. Right? I don't want to look like an outside network computer. I want to look like I belong. So it looks like I could name a computer 29201A9 and no one would notice the difference. So I can be on the network and I can assume an identity for a computer system that looks like normal. 1 minute, Wireshark. This gives me a way to hide now. I can hide on the network. It's still going. Right? So now that I know what all this stuff looks like, a workstation, car, 29306D, bunches of cool stuff. Right? So now I know how the Microsoft network's actually put together. I know we have it by building and room number. I know we have it by personal name. That's exactly how the naming convention here at this company works. So we're not going to name my computer Hackamundo. Right? We'll name it Amelia 2. A. Phillips 2. Because no one will think that she doesn't have. This is Katie Lawrence's computer. Dr. Lawrence up on the 3rd floor. Right? Anybody know what this is? CDP, VTP, DDP, page, ULUD, CDP, device ID, version O2E, HCNet, gigabit Ethernet, port 013. Nope. So we know that it's a frame, right? We know that it's an Ethernet frame. We know that it's, yep. We know that it's Ethernet. So the protocols in the frame: Ethernet, LLC, CDP, and data. Right? And then the coloring rule string. We know that it's HSRP, egrep, BGP. What is BGP? Border Gateway Protocol. So this is where Cisco starts talking to the big boxes to set up the routes between buildings. Now I know where the Cisco router is actually located. Right? And I know that it's Cisco. And I know that it will accept these virtual data transports. I know that it will work on a gigabit Ethernet. I know that it's basically channel 2. Yep. Open shortest path first. Open shortest path first. That's another gateway routing protocol, but it's a more advanced one than the old BGP. BGP is pretty old. So again, we keep on upgrading things every couple of years. But now I know where the Cisco router is. I know what its MAC address is. So if I was to fake its MAC address, I can become the router for the entire building, which is better. That's a target that I would love to become. What's Dropbox? It's an online storage. The software client that uses Dropbox, the one that you actually download and put on your computer, uses what's called a LAN sync discovery protocol to find all the other Dropbox computers on the network. Right? Anybody familiar with Dropbox? It's just addressable via a URL, and any of their public documents you can get to. Once you start seeing who's running Dropbox, you can actually go back through and see their public documents, pretty much so by finding out just by going there and mounting it. Right? So now we know that this school uses a lot of Dropbox, and that is definitely an attack vector. That is a really cool way for me to fake being the Dropbox server and getting everyone to cough over all of their documents. All I've got to do is inject a DNS entry that I'm Dropbox.com. So there's my first attack vector. So what have I discovered in the last 10 minutes? Just by running a wire sniffer for 1 minute. I've got a lot of the infrastructure. I know we're using primarily Windows Network. I've got the naming convention, and now I have a hook. Now I've got a way to kind of force my way in the door. 10 minutes worth of work. Not bad. And lots of computers are using Dropbox. I mean, just a ton of computers use Dropbox here. Right? All right. DHCP. Someone just booted up off the network. So there's a transaction ID for that specific computer to get that specific lease on the IP address. If I have the transaction ID, can I go ahead and forge a DHCP entry with the same transaction ID and then turn around and start doing illegal things? You can. There's my second hook. Right? As long as I have the transaction ID that shows up and I know what the IP address is, I can fake them out. I'll just hang out till 5 o'clock, wait for them to shut down and go home, and then I'll assume their IP address and their MAC address. And I'll look just like anyone else. Which one of these actually shows up as a glaring weird thing? That should worry you. As a security engineer, that one should worry you. In nature, the IP address quad zip doesn't exist. All right, so there's something kind of weird going on with the DHCP server, which may give me another hook into the system if it's misconfigured. Misconfigured computer systems are the best thing you can ever do for a hacker. Honest to God. I will love you forever if you continue to misconfigure computers. DHCP version 6, do we use it here at the school? Do we use any IPv6 here at the school? Not yet. We don't even use it for inter-building routing. So if they're offering DHCP and IP version 6, that gives me another channel to talk on. Because everyone's getting an IP6 route and everyone's getting an IP6 IP address. They're going to be mostly monitoring TCP/IP, IPv4, not version 6. So that gives me my covert route for talking and getting data out of the building, which is like really, really, really cool. Now I have a covert route. So I can now bury all my communications in a way that they won't recognize because they're not monitoring for it. All right. What is dynamic trunking protocol? We know it's coming from the Cisco. What's the routing here? Yep, what is a trunking protocol? Someone go look that up real quick. What is Cisco Dynamic Trunking Protocol? Because we know it's coming off the Cisco router. We know what it will carry as protocols. All right, so if it's VLANs, that's even... All right, so that's cool. If it's VLANs, then that means that's a virtual local area network. So now I've got more about how the network is engineered because they're using VLANs. So that means they may actually have even more cooler data buried in the system, so I'm going to want to become part of that VLAN if I possibly can. Because what I really want is the cool data. I want your email, I want your payroll, I want your human resources, I want every single student ID here at the school. Right? So kind of interesting. So if I know that they're doing that, then I'm in pretty good shape. What is CCM post? What is this? So if we look at the packets, so 7544 bits, right? So we have the inside of the packets. We actually have the data that was going across. So we know it was an octet stream. It was an application octet stream, right? So when we know that it was internal, So the source is 10.29.99.138 going off to 10.126.111. Right? So we've got something a little bit hokey here in terms of protocols that may actually be interesting to go try to figure out what they are and how they work. What's a router solicitation? An ICMP, everybody know what ICMP is, right? What's a router solicitation from a MAC address? From an IPv6 IP address to a router for a router solicitation from. Yep. So the cool part, can I bury data in ICMP, or does it have to remain 0? Same thing. So I can actually have some fun with this and actually start building stuff, especially if they've got the listener going on. Right? Listeners are good. What's a membership report for IGMP version 1? What's IGMP? Okay, so now we're starting to know who all the gateways are. And the minute I can start building out who all's got the gateways, I can actually start drawing a network map and start figuring out all this stuff. Once I've got the group report number, I know how things are going to start routing across that network. Right? Because one of the things I want to do is I want to dive as deep into this network as possible. Once I can start doing a network map, I know we're using layers, I know we're using ICMP, I know we're using a lot of these other kind of interesting protocols along the way. So I can kind of have some fun with this. We've got join and leaves. So I can actually go through and actually join, and now I know I can actually join and leave as a general product. Right? And I know that 2 and 253 are our big boys that I need to pay attention to. Right? Cabletron and TerraSys. What is ISMP? What was it? ISMP. India Sierra Michael Papa. Integrated Source Management Protocol. What can I do if I've got the IP address for a management system, for a network management system? I'm going to make that a priority target. Right? Honestly, because if I can get in there and take over the network management system, I'll just route everything through the building off campus to my own server and then forward it from there. And I'll drop it into Amazon's cloud, and I can record everything coming in and off the campus. No one will know. By the time I'm done with it, no one will know. And this is why all good security engineers are part-time network engineers. Right? The more you know about why things work the way they work, then you can figure out ways of getting them to do your bidding rather than what the system administrator really wanted it to do. Right? And TerraSys slow protocols. What is a link aggregation? What's a slow protocol? All right. And then we got a bunch of other. Oh, we got some Apple devices here. What's LLC? Why is an Apple device broadcasting? So again, if we're seeing Apple devices and HTC, what's HTC? It's a mobile device. What's an Apple device? How about Samsung? What's the security? What's the security around my phone? Most of it is just take the stock phone out of the AT&T store or out of the Verizon store or T-Mobile store, and we don't worry about it, right? We rely on the vendor to secure these things for us. And that means that there's all sorts of weird things inside that phone that we have no idea what to do with. And mobile systems are some of the most attractive targets out there because everything's on them. All right, there's a reason why whenever I come back from China, the first thing they do is take my phone and go make a copy of it. Right? Because I'm more likely to take casual snaps with my cell phone than anything else. They don't want to go through the thousands of pictures I'm bringing back on the big camera. They want to go through what's on my cell phone because they want to know who I was talking to. Right? And I've been stopped at the border twice now, which is entertaining. It's an entertaining experience. But as soon as I've got people's phones, what is a Muratma phone? I have no idea. Right? But again, once you start figuring out what devices, if it's BYOD, bring your own device. Right? Yep, there's a lot of interesting things I can do because these devices may or may not necessarily be as secure as the computers that are actually on the network. The network, according to the acceptable use policy, here is antivirus and firewalls and all the rest of it. This don't.
It's kind of weird too. There's a lot of federal. NIH has a bring your own phone policy. A lot of big federal agencies do. Kind of crazy.
Darn straight. So those phones may give me a way into corporate data that the harder targets internal may not be something I want to deal with, right? So I may go after your phone because it's an easier target. And now that I have your MAC address and I know what your model name is, I'll just go ahead and have some fun with it because I can route via MAC addresses. What is LLMNR as a protocol? What is it? Link local multicast. All right. Name resolution. Link local multicast name resolution. A standard query. OXDA04 Windows. All right. You're going to see this on a lot of Windows networks, but it's just the way that Windows networks talk to each other, so that you can see stuff like this. There's 194 computers within the range of what I see. Everybody remember how to? I don't actually want to do it that way. What I want to do is I want to open a new window. So what we can see real quick is whether my credentials right now that I've got will allow me access to that computer through the shares, the $, right? And I may or may not be able to get into it that way. But again, lots of interesting things. Who's Bob? Yep, so can't access that. So that's cool, right? That's what we want to see. But you can just sit here and then go. So someone's left their system volume open and their net login share open. Run my info, password stuff. So what's inside of there? So now we have a name for a server called Anno Domini that goes then and launches off a program called PWB at talk.highline.edu from one of the kiosks. Yep. And that actually looks like a program. Ooh, activity text. Ah, darn, there's nothing in there. But again, see, that's kind of the whole idea behind this, is what can I get in there and grab, what can I not get in there. Save as error text. No errors. Errors will give me a good chance to do and find things. Right? Favorites. What are their favorites? Probably nothing. So it kind of makes sense on how much fun this can be. Just by opening up stuff. Windows networks are great. Alright, what does it mean when it's red? And then what is MD November Sierra? What is MDNS? Yep. So, if we see a sub Apple, right? So we know that this is an Apple protocol. And we know that it was local. Sub Apple Mobile Development 2, TCP local. All right, so this actually points to inside of a program on someone's iPhone. So the mobile development kit that comes with a lot of Apple programs, if a security engineer, you have to become part programmer too. You kind of have to become a jack of all trades, right? Databases, mobile systems, routers, switches, programming, you name it. You kind of got to know a little bit about a lot of things, right? So if they're pulling that stub, Apple ModeDev 2, is there a security flaw within that that I can then go ahead and then use to get access to the device? Because all code has flaws. Code is a human expression of what we do. When we come in on Monday morning, we're kind of dragging butt. When we're leaving on Friday afternoon, we're kind of like, just let me get this done so I can go home, right? So whenever we write code, there will always be some kind of flaw in it. You can't help that. That's a human system, right? So is there something in there then that I can actually go through and use to kind of make my day a little bit easier, a little bit more interesting, right? So all that. And there's a lot of stuff. Ooh, help desk. I love help desk. So there's some help desk computers here that we could actually use. Natalie Morge's MacBook. I love the naming convention here. So if we know it's a MacBook, we know it's probably running the latest operating system, or even better, it's running an older operating system. How often does Apple patch? Once every year. Unless it's really, really bad, then it's once a quarter. And then that's only if you actually manually go back and say, patch my computer. Unless you have the update system for Apple. All right, so again, lots of really, really cool stuff in just a little simple, quick capture, right? And we got some more stuff. Alert, cwu.edu, who's got it, right? So anything that's name query, right? Who's got WPAD00? So if we're actually getting some stuff off CWU, that would be an interesting way of managing the network, right? We shouldn't be seeing anything from CWU at all. Shouldn't be. Best laid plans. All right, everybody knows what TCP IP is? All right, anybody know what a spanning tree is? Spanning tree is a way of recalculating costs of a network, right? So the network is constantly recalculating which is the nearest hop first. TCP segment of assembled PDU, TCP going from 99.138 to 206.40. This, by the way, is me actually recording this, right? Just because I recognize all this stuff from last time. But this is what someone recording on Tegrity looks like, right? This is what someone actually doing on Microsoft DS, an actual sequence lookup. Right? Nitrogen. Nitrogen is one of the servers for Tegrity. We actually had to go look all this stuff up. That's the only reason why I know this. Because nitrogen is also a service type that's got more holes than Swiss cheese. And I was really, 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 really hoping that it wasn't Tegrity. But it ended up being Tegrity. Right? HTTPS. So we're running encrypted. What happens if you see an RST? What's RST mean? Reset. What happens if it sends a reset?
It's basically sending something there, but not leaving a trace.
Yeah. It means that I'm sending data too fast for the receiving computer. So the receiving computer will send me a reset saying, hey, you need to slow it down, mister. Right? And that's really what a reset is. It can also be used to completely drop a channel, right, and force that TCP handshake again. So if I'm going to take over and be a router, I'm going to send a reset across the entire network and force them to TCP IP handshake with my computer, right? Especially if I want to monitor or pull something out of that data stream. Man-in-the-middle attacks.
Why can you use packets in their source and destination? I mean, why are you able to see them?
I am able to see any packet that's from me to someplace else or from someplace else to me, unless it's a broadcast, because I am on a switched network. So because we're using the instructor computer in here, it's a completely different process than the student computers in here that you guys have got. This is the stuff that actually happens on the Highline network is tons more interesting than what happens on the isolated network in here that you guys are on. So that's why I kind of did this up on the instructor computer. It's because there's a lot more cool stuff.
But I mean, shouldn't it just go from source to destination?
No, because we loaded WinPCAP. So when we loaded WinPCAP, we told our NIC card to go into what's called promiscuous mode and listen to everything and report it to me. That's why WinPCAP is really important. Huh? The switch will send me anything that's broadcast or directed to me. That's the switch's function.
So all of these are direct.
Some of it's broadcast, some of it's routing. Cisco will drop protocols everywhere. Microsoft will drop protocols everywhere.
Your IP address is 40.
No, mine's 10.29.99.138.
Oh, okay.
So that's me. Right? Yep. So of all the packets here, we just have this little small amount that's me actually doing stuff. Right? So think about it. What's the overhead of this network? How much bandwidth am I wasting just running the network as the network? I am wasting a lot of bandwidth. Oh, no, they don't see me now. Right? Anybody know what magic packet is? I haven't seen this one before. 98.33, sending it out to the broadcast across the entire Class A network. The protocol is WOL. Someone look that one up for me. What is the protocol WOL? Wake on LAN. Interesting. So why would we get Wake on LAN doing Intel, Toshiba? Why would one box with the same IP address send a magic packet for Intel, Toshiba, Dell, Hanhai, Gateway? That's an interesting kind of thing. Arcadian. That's really interesting. So that may be something I would want to go research further, because that may be something I could actually have some fun with later on down the road. Free system administration. Oh, there's always a price. Right? There's always a price. And then we've got some Groove stuff going on. But yeah, no. So look, we've only got like about maybe 30% of the packets that we captured are just actual data packets, right? The rest of it's all management, control, and all the rest of it. So what does that do for network management? Right? So there's going to be a lot of network management stuff that's kind of interesting. Now, here's the question. If 70% of the traffic on this network is network management traffic, that will be ordinary. That's normal for what we see on this network. For what the network engineers are looking for, this is normal. If the majority of the traffic is network management traffic, how hard would it be for me, now that I've identified network managers, the protocols they're using, what kind of routing system that we're using? I've got a couple of VPNs, a couple of layers, fabrics on the network. I know all this. For me to slide in is another routing management system. How hard would that be? Not very. Right? So that's why when you're doing hacking, you really want to see what's going on their network, because you want to be as ordinary and as normal as possible. Right? You want to be just like everybody else. You want the same naming convention. You want the same IP address. You want a MAC address of hardware that's at least somewhat recognizable. Right? You want to look normal. And that's one of the biggest things I find the most interesting. So your assignment tonight is to go home, load up Wireshark, and see what's coming in off your ISP. Just load it on your home PC, run it for a couple minutes, right? We don't have a Dropbox in this class, so you don't have to share it with me. But go through that, just like we did here in class. So the video will be up tonight. But go through it, just like we did in class. What's normal coming across your network? If you're on Comcast, you're going to giggle. I swear to God, you're going to giggle like a little schoolgirl or a little schoolboy. It's hilarious, the amount of stuff that the Comcast does to manage their network. If you're on Quest, not so much, or on CenturyLink, right? But that's your homework assignment. Come in on Friday and be ready to talk about what you see on your home network. If you have kids, it's going to be even more hilarious, right? So it kind of makes sense? Got any questions? Are we good?
Is there a way to, tell the switch to send you all the information like that previously?
Is there a way for a switch to tell you to send you all the data? To send me all the data? Yes. You have to force the switch into hub mode, which means you actually have to ARP poison the network so that it will drop into hub mode. There is a way to do it. They may or may not. It depends on how sophisticated their network engineers are. The ones here would notice. The ones here would notice.